Take this particular example, Rama underscore Ramar. Okay. Now, how many characters are there? R, A, M underscore 4. Therefore, M is nothing but a log of 4 with the base 2, which is nothing but the 2. So, once I will get this one, now you construct the tree for that one. So, 2 means either it will be 0, 0, 0, 1, 1, 0 or an 1, 1. So, how to construct the tree for that one? It is very simple. So, only the 2 levels of the tree you will be having 0, 1, 2 or a 2 edges far you will have. So, it is 0, 1, 2 and what are the characters? R, A, M, A. Okay. So, now towards a left 0, towards the right one 0, 1, 0, 1. So, what is the code word? You got it for R 0, 0 and for A it is 0, 1 and for M it is 1, 0 and for A it is 1, 1. So, these are the code words what you have generated and how you will encode it for this particular text Rama Ramar. So, it is nothing but R 0, 0, A 0, 1, M 1, 0, A 0, 1 underscore. Okay, underscore I have not written. Okay, A is repeated. This is underscore. Underscore is 1, 1. Then R 0, 0, A 0, 1, M 1, 0, A 0, 1, R 0, 0. So, this is what the encoding message you got for this particular text. And towards the receiver side, what they will do? They will read the 2 characters. 0, 0 is nothing but a R and next 2 characters 0, 1 is nothing but A. Like this they will decode it. That is called decoding and sending this one is called as an encoding. Now what is the use of this generating the code word? Is it is going to save the text and all the thing. So assume that I am sending the text as it is. I am sending the text as it is. So in that situation, how many bit the each character will take? Assume that, not assuming, each character will take the 8 bit. Okay, you already all of you know that. So how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. Okay, into 8. 10 into 8. So it is how much? 80. 80 bits of memory is required in order to send this particular data. Assume that this particular text is occurred in the document. In the document, this particular text has been occurred 100 times. So, it is into 100. So, 8000 bits are required. 8000 bits are required in order to send this text. Okay. If it is occurring 100 times. Same Rama Rama, I have written 100 times. So, how many bits of memory are required to send this data from sender side to the receiver side? 8000 bits of the memory I require to send that one from the source to the destination. Got it. Now, come to this one. Same information. Now, I have encoded here. So, how many bits are there? 0 will take 1 bit. It is a binary bits what we are having. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 bits is enough to send it for once. How many times this is occurring in the document? 100 times it is occurring. So 20 into 100. So 2000 bits of data I require in order to send this particular data. So how many we require here? 8000 bits memory I require in order to send the document where Rama Ramar has been written 100 times. Whereas if I code it, encode it by using a fixed length encoding technique, then how many bits I require? I require 2000 bits of the memory location in order to send the same information but it in a encoded format. So that is the difference between the text, sending the text as it is and sending the data after encoding. Okay, that is only for the small text. How much? 6 bits of the memory has been saved. So think about a very large text because usually encoding and decoding techniques will not be used for an smaller data. Okay, data with a smaller size. Usually they will use it for a file with a larger size. And also one more important thing, what is the purpose of only not the compressing the data is not the purpose of encoding and decoding. One more purpose of doing encoding and decoding is the security. No one can hack that information. If any important messages are there, then you can use the this encoding and the decoding concepts. So this is one of the technique that is used for encoding the data. Okay, that is about a fixed length encoding. What is the disadvantage of this fixed length encoding? So obviously, what is the disadvantages? So even though the data is occurring, that is character is occurring more number of a time or a smaller number of a time, the same code word of a same size will be unused. Okay, suppose here R is occurring how many time? 1 time, 2 time, 3 time. So for R also I am using the code word of length 2. Underscore is occurring how many time? Only 1 time. For that also I am using a code word of length 2. So what I can do is, the one which is occurring more number of a time, I can keep a code word for that is of length 1. Okay. If I'll keep the code word, some code word for the R of length 1. Okay. 1 indicate R. Like that. How many time A is occurring? 1, 2, 3, 4. So for that also, if I'll keep the code word of length 1, and for M which is occurring only 2 time, I can keep the code word of length 2, and underscore is occurring 1 time, I can keep the code word of length 3 here. If I'll keep like this, then the number of the bits will still reduce, because R is occurring more number of a time, and what is the length of the code word I am using here? Only 1. Okay. So instead of keeping the code word length there 2, I am keeping the code word length as an 1. Therefore, still I can reduce the number of the bits that is used to send this particular data. So that is called as a variable length encoding technique, where for a different character you may have a different code word of a different length. Okay, that we'll see it in the next class. Okay, thank you.